Hey there, welcome back to Victory Education Lounge. I'm your host Maurice, and today we are talking about a groundbreaking topic in the fight against malaria, vaccines. This is part 20 of our ongoing malaria series, where we'll be discussing the current progress and future prospects of malaria vaccines. If you're excited to learn more about this cutting-edge development in global health, make sure to hit that like button, subscribe, and leave your thoughts or experiences with malaria vaccines in the comments below. I love hearing from you. For many years, our battle against malaria has largely been about prevention. We've relied on tools like bed nets, indoor residual spraying, and anti-malarial medications, but now we're on the brink of a potential game changer, vaccines that could protect us from this lethal disease. Malaria isn't like most of the diseases we vaccinate against. It's caused by a complicated parasite called Plasmodium, not a simple virus or bacterium. This complexity has made the development of a malaria vaccine incredibly challenging. But after decades of scientific struggle, we're starting to see results. The world's gaze is currently focused on one particular vaccine that's made it to the finish line, and there are several others hot on its heels. These vaccines are showing promising results, and they could be just what we need to turn the tide in our fight against malaria. The first of these vaccines, RTS S/ACE01 or Mosquirix, has been developed over 3 decades of research. It targets the deadliest species of malaria parasite, Plasmodium falciparum, which is especially prevalent in sub-Saharan Africa. In 2021, the World Health Organization gave the green light for Mosquirix to be used widely, making it the first approved malaria vaccine. Mosquirix works by priming the immune system to recognize and attack the parasite before it can mature and cause severe illness. In large-scale clinical trials, it reduced malaria cases by about 30% in young children. This is a significant step forward, but it's not perfect. So what's the state of malaria vaccines today, and what does the future hold? Let's explore. First, let's talk about the RTS S/A01 vaccine, also known as Mosquirix, the first malaria vaccine to be approved for use. The journey to this groundbreaking development stretches over 3 decades of intense research, trial, and collaboration. Mosquirix is an ingenious tool specifically designed to target the Plasmodium falciparum, the deadliest species of malaria parasite prevalent in sub-Saharan Africa. The process of creating this vaccine wasn't a walk in the park. Unlike viruses or bacteria, the Plasmodium parasite is complex and tricky to target. However, after years of perseverance, the developers of Mosquirix found a way to outsmart the parasite. The vaccine functions by stimulating the immune system to recognize and fight off the parasite before it can mature and cause severe illness. It's like giving your body a sneak peek of the enemy so it can prepare for battle. In 2021, the World Health Organization gave the green light for widespread use of Mosquirix, marking a significant milestone in the fight against malaria. This approval didn't come easily. It was based on the results from large-scale clinical trials which demonstrated the vaccine's ability to reduce the number of malaria cases. These trials, which involved thousands of young children, showed that RTS reduced malaria cases by about 30%. While this might not seem like a lot compared to the high efficacy rates of some other vaccines, it's a promising step forward in the battle against this deadly disease. When you consider that there were an estimated 209 million cases of malaria worldwide in 2019, a 30% reduction could mean millions of lives saved. But, as with any scientific advancement, Mosquirix is not without its limitations. It's not a silver bullet, and it doesn't provide total protection against malaria. Yet, it's a powerful tool that can be used in combination with other prevention strategies like bed nets and anti-malarial medications to reduce the burden of malaria. In large-scale clinical trials, RTS was shown to reduce malaria cases by about 30% in young children. A promising step forward, although it's not perfect. Now let's look at the pros and cons of Mosquirix. Diving into the benefits first, Mosquirix is a pioneer. It's the world's first malaria vaccine, a significant milestone in the global health landscape. In the fight against this deadly disease, Mosquirix has proven to be a potent weapon. Clinical trials have shown that it reduces malaria cases by around 30%, particularly in high-risk areas such as sub-Saharan Africa. Furthermore, Mosquirix targets the most vulnerable group, children. In the global context, children bear the brunt of malaria, accounting for the majority of malaria-related deaths. Therefore, a vaccine that specifically protects this group is a leap forward. Besides, The vaccine has shown to be safe, with side effects being manageable and mostly minor, such as mild fever or fatigue after the injection. However, even with these benefits, there are some drawbacks to consider. First, the efficacy rate of Mosquirix, while significant, is moderate. The reduction of malaria cases by about 30% is far from the efficacy seen in vaccines for other diseases, like measles or polio, which boast over 90% efficacy rates. Then, there's the issue of dosage. Mosquirix requires 4 doses to provide full protection. This can pose a logistical challenge, especially in low-resource settings where access to healthcare facilities might be limited, and keeping track of vaccination schedules can be challenging. Lastly, the duration of protection offered by Mosquirix is another concern. The immunity gained from the vaccine tends to wane over time, meaning booster doses may be necessary to maintain its effectiveness. This adds another layer to the logistical challenge, particularly in regions where healthcare systems are already stretched thin. Despite these challenges, the advent of Mosquirix is a big step forward in the fight against malaria. It symbolizes the progress we've made and the potential of what we can achieve in the future. While it's not a silver bullet, it's a valuable tool in our arsenal. Remember, the fight against malaria is a marathon, not a sprint. Immunity wanes over time, so booster doses may be necessary. But RTS S isn't the only vaccine in the works. Researchers around the world are working on several other candidates that could change the landscape of malaria prevention. First up is the R21/Matrix-M vaccine. Currently in phase 3 clinical trials, this vaccine has shown an efficacy rate of up to 77% in early studies. That's a significant improvement over RTS S. If successful, this vaccine could provide a more effective tool in the fight against malaria. The R21/Matrix-M vaccine was developed by the University of Oxford and partners, the same team that brought us the AstraZeneca COVID-19 vaccine. It uses a similar technology, taking a protein from the malaria parasite and fusing it with a protein from the hepatitis B virus to stimulate an immune response. Next we have the PfSPZ vaccine, developed by Malaria. This vaccine takes a unique approach by using live, weakened malaria parasites. The parasites are irradiated to render them harmless, then injected into the body. This approach has shown promising results in early trials, but more research is needed to determine its effectiveness in larger populations and over longer periods of time. There's also the GMZ2 vaccine, a product of an international collaboration. This vaccine targets a different stage of the malaria parasite's life cycle, aiming to stop the parasite from multiplying in the blood. In early trials, GMZ2 has shown a good safety profile and some efficacy, but it's still in the early stages of testing. Lastly, we have the PfSPZ CE-VAC vaccine, another candidate from Malaria. This vaccine also uses live, weakened parasites, but with a twist. It's administered alongside an anti-malarial drug that kills the parasites once they enter the liver, teaching the immune system how to fight off the infection in the process. These are just a few of the exciting vaccines currently under development. Each one takes a unique approach, targeting different stages of the malaria parasite's life cycle, or using different methods to stimulate the immune system. If successful, these new vaccines could significantly improve our ability to prevent and control malaria. As we look to the future, the potential of malaria vaccines is clear. The innovation of vaccines like RTS S and the promising prospects of others like R21/Matrix-M signifies a paradigm shift in the global health community's approach to combating malaria. The primary goal for the future is improved efficacy. While RTS S has made a significant impact with a 30% reduction in malaria cases, vaccines like R21/Matrix-M are aiming for even higher efficacy rates. Early studies have shown a promising efficacy rate of up to 77%, which could drastically change the dynamics of malaria prevention. Another key focus is the wider distribution of vaccines. Currently, the RTS S vaccine is primarily deployed in sub-Saharan Africa. Future efforts will aim to expand the reach of these vaccines to other malaria-affected regions. This will require strategic planning, resources, and international cooperation to ensure vaccines reach the people who need them most. Ongoing research and development are also crucial for future prospects. Scientists are exploring innovative techniques such as using genetically modified mosquitoes to deliver vaccines, or developing vaccines that target multiple strains of the malaria parasite. These advancements could lead to more effective and wide-ranging tools in the fight against malaria. Looking beyond the scientific aspect, it's essential to consider the socioeconomic benefits of malaria vaccines. Reduced malaria cases mean fewer hospital visits, less time off work, and more productive communities. In the long run, this could contribute to the economic growth of malaria-affected regions, creating a ripple effect of positive change. In conclusion, the journey towards a world free from malaria is a challenging one, but with the advent of malaria vaccines, we're closer than ever to turning this dream into reality. The progress made so far is a testament to human ingenuity, resilience, and the collective will to overcome one of the world's deadliest diseases. Before we wrap up, I want to emphasize that while we've covered a lot of ground today, there's still so much to learn about malaria. This video is just another step on our journey to understand and combat this disease. In the coming weeks, we'll continue to dive deeper into each aspect of malaria, from its life cycle to the latest research in vaccine development. If you're passionate about making a difference, I invite you to support the fight against malaria by visiting United to Beat Malaria. You'll find the link in the description below. Together we can help save lives and create a healthier world. Every contribution, no matter how small, brings us one step closer to a world free from malaria. Remember to like, subscribe, and share your thoughts in the comments. Together we can unveil the truths about malaria and join the battle to end this global menace. Disclaimer: the information provided in this video is for educational and entertainment purposes only. Any health-related decisions should be discussed with a licensed physician. Always seek the advice of your doctor or other qualified health provider with any questions you may have regarding a medical condition.